Hello everyone, welcome back to C++ Advanced. Today's topic is casting. I don't know about you guys, but for me, casting has always been a confusing topic. Now, exactly what is casting? C++ is a strongly typed language, so an object can be converted from one type to another. Generally speaking, there are two kinds of type conversion. One is implicit type conversion, another one is explicit type conversion. Explicit type of conversion is also called casting. There are four casting operators in C++. Static cast, dynamic cast, const cast, and lastly, reinterpret cast. Let's start with the static cast. Static cast can convert an object from one type to another. Here I define an integer I equal to 9, and then I cast I from an integer to a float. Static cast can work on any type as long as the type conversion is defined for those types. Here I create a string Bob and then cast the string to a dog. The condition for this statement to work is the type conversion is defined for the conversion from string to dog. We've talked about the type conversion in previous sessions, so I won't talk about that here. Static cast can also work on pointers or reference. And for pointer and reference, it can only cast an object from one type to a related type. That means you can cast an object from a base class down to a derived class, or cast it from a derived class up to a base class. In this example, my yellow dog is derived from dog, and after I create a yellow dog, I can cast the pointer to a dog's pointer. This is static cast. Now let's look at dynamic cast. First I create a yellow dog and then cast its pointer to a dog's pointer. Now this is a static cast, even though I'm not using the static cast operator. Then I cast the dog's pointer PD back to yellow dog's pointer PY. Dynamic cast can only work on pointers or references. It cannot work on an object. And it converts from one type to a related type. And typically it will be used in downcast, which means it casts an object from its base class to a derived class. In this case, from dog to a yellow dog. Another difference from the static cast is the dynamic cast, in addition to performing the type casting, it also performs a runtime type check. It will check if the types are compatible for the casting to succeed. In this case, it will check if the PD is pointing to a yellow dog, a real yellow dog, and not just a dog. And if the casting succeeds, the PY will become PD. And if it fails, PY will equal to 0. It's a null pointer. And finally, the dynamic cast requires the two types to be polymorphic, which means they need to at least have one virtual function. Now let's look at const cast. Const cast is used to cast away the constness. In the example, I have a const char pointer string points to hello world, and the hello world cannot be modified because it defines to be a const. Then I use const cast to cast away the constness and then assign the result to a modifiable char pointer, and now the hello world can be changed. And like dynamic cast, the const cast can only work on pointers or references. It cannot work on the object itself. So if I change this char to a char pointer to char, and it doesn't work that way. And unlike the dynamic cast, the const cast can only work on same type. So both string and modifiable are both char pointers. The only difference is one is a const and another one is not a const. Our last cast operator is reinterpret cast. In this example, I have a p pointer which points to some address, and then I use reinterpret cast to interpret the memory content in that address into a dog. The reinterpret cast can also work on can only work on pointers or references. It cannot work on the object itself. And if you compare to the previous three casts that works on pointers or references, the static cast is working on related type, and the dynamic cast also can work on related type. The const cast can only work on same type, and the reinterpret cast can work on any type. You can cast from one pointer to any other type of pointer with the reinterpret cast. So this is the most powerful cast, and because it is so powerful, it also gives you a lot of room to make mistakes. That is why you always need to use extra caution when using reinterpret cast. Typically, reinterpret cast is used in low-level coding because it tends to generate code that's not portable. C++ also inherited the old-fashioned casting style from C. Let's call it C-style casting. And C-style casting has two forms. One is the C-like casting notation, another is the functional notation. In this example, I have a short integer a, and I cast it into I and j. And both formats are the same. There's no difference between them. A C-style casting is really a mixture of static cast, const cast, and reinterpret cast. The only cast that it doesn't support is the dynamic cast. So now we have C-style casting, which does the exact same thing as the 3 C++ style cast. Then which one should I use? In general, the C++ style of cast are preferred over the C style. The reasons are, first of all, it's easier to identify in the code. By grabbing underscore cast, you can easily find out all the C++ style of casting in your code. Secondly, the C++ style of cast tends to generate less usage error. That is because there are 4 different types of cast in C++, and each one have a narrowly specified purpose. So that gives you less room to make mistakes. And also C++ style cast provide a runtime type check capability to check if the types are compatible for casting. So that is also a powerful tool to use.